Hello my beautiful students, I guess you people are doing well. Your PU2 examination preparation, and along with that you are also preparing for the KCET, right? So I am here today with your most requested video, that is a PYQ solving video, and here I am covering 30 PYQs from the chapter Solution and Chemical Kinetics. So I actually tried to cover the last 5 years and the most repeated type of questions here. So before moving towards the question, let's just understand a little bit about the chapter, like what is a distribution, how many question in which year it actually came. So if you just look at that, the solution and chemical kinetics, the number of question in these year, it came the maximum. So that's the reason I started with these chapters. Later on we will thoroughly cover all this chapter, and I'm assuring you, please continue watching till end. It's gonna be very much beneficial for you. As you know, we don't only solve the question, rather we understand the concepts hidden in the question as well. So yes, stay tuned, it's going to be a very exciting one. Let's get started. So we are going to start from the solution chapter itself. So as you can see, here comes the first question. So first question, it is coming from the concentration term. See, which of the following methods of expressing concentration are unitless? So first option is molality and mole fraction, mass percentage and molality, molality and molarity, mole fraction and mass percentage. So let me tell you the answer at first for this question. So for this particular question, this is going to be the correct option. Now let me tell you why the other options are wrong and why this is the correct one, right? So first, if you just look at the molality, in general, by definition, what we write, it is actually the number of moles of solute in particular volume in liter, right? So mole divided by volume. So definitely the unit will come as mole. If you write the volume in liter or decimeter cube or whatever it is, the volume unit will come. So let me just assume it in liter. So mole per liter. So definitely it's not going to be an unitless quantity, right? Now if you proceed with the mole fraction, so if you just look at the mole fraction, then mole fraction is number of moles of any solute, let's say it's A, and the total number of moles, NT. So both the cases, this is also mole and this is also mole. So numerator and denominator, they gets cancelled out. So it's an unitless quantity, right? So definitely mole fraction is one of the option. Another option, let's find out. Another thing you can see, next option, mass percentage. Okay, so mass percentage, if you write, that is the W by W, right? So how you write? So weight of the solute divided by weight of the solvent into 100, right? This is how actually we solve the mass percentage. So if you put the weight here also in gram and here also in gram, so weight, the units of the weight will be cancelled out, right? So these also going to be the unitless one. So already you got the answer. One more thing I wanted to tell, that is the molality. Okay, so molality, if you just see, by definition, it is basically number of mole present in the weight of the solvent. So this is the weight of the solvent, right, into the solvent. If you can take it in kg, weight of the solvent in kg, right? So definitely the unit is going to be mole per kg. So the unit, you can see molality and molarity, both of them are having some unit. Okay, only the mole fraction and percentage weight, they are the unitless quantity. I guess you understood this concept. Let's proceed for the next one. So here you can see an aqueous solution of alcohol contains 11 gram of water and 414 gram of ethyl alcohol, right? So the mole fraction of water you have to find out from this. So here what you have to do, so if you want to find out the mole fraction of water, what information actually we need? I need number of moles of water, I need number of moles of water in the denominator plus number of moles of ethyl alcohol or alcohol, ETOH I am writing, okay. So let's find out the mole at first, and then we will just replace the value in this particular formula and we will get the answer, okay. So if you just find out the number of moles of water, it's going to be given weight, that is the 11 gram divided by the molecular weight, that is 18 gram per mole, right. So if you calculate this, it will come around 0.61, okay, 0.61 mole, okay. Now number of moles of ETOH if you calculate, ethyl alcohol if you calculate, it's basically given 414 gram divided by, if you calculate the molecular weight of ethyl alcohol, that is the C2H5OH, it will come 46 gram per mole, right. So if you calculate this, it will almost come, it will come completely 9 whole number, okay. So 9 mole. Now what we are going to do, we are going to replace the value in this formula. So mole fraction of water is going to be 0.61 divided by 0.61 plus 9, and if you calculate this, your answer will be 0.06. So C is going to be the correct one. So I guess you understood this. Pause your screen and make sure that you are noting it down in your copy, because whenever we see, only we see the question, only we just go through the things, then sometimes we feel like yes, we understood, but until or unless you are practicing with a pen and paper, it's not gonna be helpful. Just mark my word, for chemistry, pen and paper utilization is very, very important. So make sure you're observing the video definitely, and along with that, your pen is working on a paper. That's it. Okay, let's proceed for the next one. Here you can see variation of solubility with temperature T for a gas in liquid is shown by the following graphs. So what is the correct graph, correct representation, that you have to find out. Okay, so first what is a Henry's law? If you just find out normally, or directly if you don't go to the Henry's law, indirectly also you can see, like solubility of gas solubility of gas is basically inversely proportional to T, right? Inversely proportional to T means if T increases, solubility should decrease, right? Now if you take solubility in y-axis and T in the x-axis, then with the increase in T, the solubility must decrease, right? So where the case is similar to this, you can see the case is similar in here, option B. See, as you can see, solubility is increasing and T is decreasing, right? I guess you understood this. Let's proceed for the next one. Here you can see solubility of gas in liquid increases with, then you are having option increase with P and decrease of T, decrease of P and increase of T, increase of P and increase of T, and decrease of P and increase of T. So if I just write the Henry's law from here, pressure, partial pressure equals to KH into mole fraction. Mole fraction indicates the solubility itself, right? So I can write that P is directly proportional to solubility, right? So if P increases, solubility Solubility definitely will increase. So definitely P must increase. Now let's see for the temperature. So in the last question itself, I just told you solubility of gas decreases with the increase in temperature, right? So T and S So if you just see T and S, they are inversely proportional. So in order to increase the solubility, if you want to increase the solubility, T must decrease, right? Because they are inversely proportional to each other, right? So you can see your correct option is going to be A. I guess you understood this. Let's proceed for the next one. Here comes the applications, the question that is based on the Henry's law, and you can see the year that also I mentioned here. This is just the last year question. If N2 gas is bubbled through water at 293 Kelvin, how many moles of N2 gas would dissolve in 1 liter of water? Assume N2 exerts partial pressure of 0.987 bar. Okay, so for this type of question, what you have to do, you just have to understand what datas are actually given and what they are asking, right? So they are asking like the moles of N2 that will be dissolved, the number of moles of N2 that will be dissolved. So we can calculate the number of moles from the mole fraction. From mole fraction, from where I can get the mole fraction value? From the Henry's law. Okay, so you can see I am having the Henry's law, like let's say P of N2, pressure of N2, partial pressure of N2 is equals to KH into mole fraction of N2, right? So from here I can get the information about the mole fraction, right? So now you can see mole fraction of N2 is going to be P of N2 divided by KH, right? So from here, if I just put the value, pressure of N2 is given 0.987 bar divided by here KH is given, okay, it is given in kilobar. So make sure that you are converting the unit in the same, because you are dividing it, right? So it's going to be 76480 bar. Fine. So if you calculate this, it will come around 1.29 into 10 power minus 5. Okay, bar will be cancelled out and mole fraction will come something like this. Now mole fraction of N2 is what, you know, number of moles of N2 divided by number of moles of N2 plus number of moles of, where it is making the solution? In water, sorry, in water, right? Number of moles of water. Okay, now number of moles of water, how I should get it? So see, they have given the information 1 liter of water, right? So 1 liter, as you know that the density of water is 1, right? 1 gram per cc, right? So from here you can write 1 liter is equivalent to 1000 gram, right? So number of moles of water, if you want to find out, given mole, that is, sorry, given mass, that is 1000 gram divided by molecular weight of water, that is 18 gram. If you calculate 55.5, remember this thing, okay, 55.5 mole. Okay, 1 liter of water indicates 55.5 mole, right? So here what I am going to do, number of moles of N2 divided by number of moles of N2 plus 55.5. Now you can see here in their denominator, with respect to the number of moles of water, the number of moles of nitrogen is very less, very less. So when a very small value is added to a very big value, that we can neglect. Okay, so here since number of moles of water is very bigger than that of number of moles of N2, hence we can neglect this particular term and we are getting number of moles of N2 divided by 55.5, that is nothing but the x of N2, right? So x of N2 you know, then further let's proceed with the calculation. X of N2 you know, that is 1.29 into 10 power minus 9, 1.29 into 10 power minus 5, sorry, into this 55.5, that will give you the number of moles of N2. Okay, so if you calculate this, thing, it will come as 7.16 into 10 power minus 4 mole. Okay, if you calculate this, it will come as 7.16 into 10 power minus 4 mole. So this is going to be the correct answer. Okay, so my request to you people, please pause your screen and make a note of it, so that simultaneously you are solving and you are practicing the concepts as well. Okay, I guess you are done. Let's proceed for the next one. Here you can see, here comes the next question, that is a Henry's law constant for a solubility of N2 gas in water at 298 Kelvin is given. KH value is given, right? So 1.1 into 10 power 5 atmosphere. The mole fraction of N2 in air is 0.8. The number of moles of N2 from air dissolved in 10 moles of water at 298 Kelvin at 5 atmosphere pressure. Okay, so this is also same type of question. Okay, so how we should target? At first we have to find out the partial pressure of N2. So partial pressure of N2 is nothing but the mole fraction of N2 into total pressure. Okay, so from here just put the value over there. What is the value? 0.8 is given here. 0.8 is a mole fraction of N2 into total pressure is given 5 atmosphere. Okay, so if you simply calculate it, it will come as 4 atmosphere, right? It will come as 4 atmosphere. Now what you have to do? Now simply apply the Henry's law. So if you apply the Henry's law, in accordance to Henry's law, partial pressure of N2 is equals to KH into mole fraction of N2, right? So from here, mole fraction of N2 I have to find out, that is KH divided by P of N2. KH value is given, that is 1.0 into 10 power 5 atmosphere divided by pressure of N2, partial pressure of N2, that is 4 atmosphere. Okay, so from here what information I am getting? Mole fraction of N2 is coming as 4 into, sorry, I guess this KH should be below, wait, okay, so let's make the KH below. So P of N2, pressure of N2 is how much? Let's write it once, P of N2 divided by KH, right? Now let's put the value. Pressure of N2 is 4 atmosphere divided by what is KH? What is KH? KH is 1.0 into 10 power 5 atmosphere, right? So from here I am getting the mole fraction as 4 into 10 power minus 5. Right, 4 into 10 power minus 5. Now next step is quite similar to that of the last one, right? What you have to do? From the mole fraction you have to calculate the number of moles of N2, right? So what is the mole fraction? Mole fraction of N2 is going to be number of moles of N2 divided by number of moles of N2 plus number of moles of water. Right, again that same approximation I am going to do. Very less amount of gas will be dissolved in water, so number of moles of water will be more. Small value is added with a very big value that we can neglect. So after neglecting this, my equation will be almost equals to number of moles of N2 divided by number of moles of H2O. Right, so here number of moles of H2 I guess given, it is 10 mole. So mole fraction is given as 4 into 10 power minus 5 into number of moles of H2 is given as 10 equals to number of moles of N2, and if you calculate it will come as 4 into 10 power minus 4 moles, right? Same way you have to proceed. So what is the answer? Your answer is 10 power minus 4, this one, option A. I guess you understood this concept. Pause your screen and make a note of it. I guess you are done. Let's proceed for the next one. Here you can see, choose the correct statement. KH value is same for a gas in any solution. Next comes, higher the KH value, more the solubility. Okay, one by one let's decide. KH value is not same for a gas in any solution, they differ. Okay, they have different value. Okay, next, higher the KH value, more the solubility of the gas. Okay, so let's see. I am having the Henry's equation like P equals to KH into solubility. Okay, so from here I can write KH is inversely proportional to S. Right, means if KH increases, solubility should decrease. Okay, so definitely this is gonna be the wrong one, this is the wrong one. So KH value increases on increasing the temperature for the solution. Okay, KH value increases on increasing the temperature of the solution. Yes, that's going to be the correct one. Why that's going to be the correct one? Because you can see KH is inversely proportional to solubility, and solubility is again inversely proportional to temperature. So definitely combining this 1 and 2, I can tell that KH is directly proportional to T. Right? So KH value increases on increasing the temperature, that's gonna be the correct one. I guess you understood this concept. Let's proceed for the next one. Okay, so the value of KH of argon, carbon dioxide, formaldehyde, and okay, so this gonna be methane. Okay, this gonna be methane, just for a typing mistake, are respectively given like this, the increasing order of the solubility. Okay, so you can see increasing order of the solubility, this is also targeting the same zone. You can see KH is inversely proportional to S, right? So lesser the KH value, more the solubility. Lesser the KH value, more solubility. Right? So with that perspective, you can see 1 means argon is having the least value. Wait, they are inversely proportional. So argon is having the least value. So it is maximum. Argon is having the maximum value, 40.3. This is the maximum. Then this. Then this. Okay. So argon solubility is the less. Okay, argon is having the maximum value, hence the solubility of argon is less. So 1 is coming first, then 2, then 3, then 4, right? Okay, 1, 2, then it comes this one, 1, 2, 4, then 3. Okay, so this is going to be the correct option. Okay, just go through the order of the KH value that is given over here, and in accordance to that you can just proceed. Okay, so if you even don't understand, let me just proceed with the value. First value is 40.3, second value is 1.67, third value is 0.413. So this is my 1, this is my 2, this is my 4, and then comes 1.83 into 10 power minus 5, that is the third one, right? So that's going to be the order. Okay, the solubility increases like that. I guess it's clear. Let's proceed further. Now this particular thing is from the Raoult's law. Okay, the vapor pressure of a pure liquids A and B are given. If the total vapor pressure of the mixture is 600 mm of Hg, the composition of the mixture you have to find out. Simply you have to just directly apply the Raoult's law. So what is the Raoult's law? That is the P total is equals to what are the component? A and B, right? XA into PA0 plus xb into PB0. Okay, now what we can do is that particular technique, xb can be written as 1 minus xa, and if you substitute this over here, your PT will be, your P total will be, if you substitute xb here, your PT will be xa into PA0 plus PB0 into 1 minus xa, right. So now substitute all the value that is given here in this equation. So P total is given as 600 mm, you can see. So 600 mm let's put. Now you can see xa that I have to find out. Okay, PA0 means vapor pressure of A, that is 450, right. So let's put 450 plus PB0 is also given, that is the 700. So let's put 700 here. So 700 into 1 minus xa. Now simple calculation you have to proceed with. So you can see 600 equals to xa of 450 plus 700 minus 700 xa, right. From here I am getting 600 minus 700 equals to xa, if I take common, 450 minus 700, right. Now what you have to do, from here I am getting 100 and from here I am getting xa into minus 250, right. Okay, so both the side minus will be cancelled out, so xa is going to be 100 by 250, hence I am getting 0.4, right. So xa I got. Now xb, how I should find out? Xb equals to 1 minus xa, right. So 1 minus 0.4, that's going to be 0.6. I guess option B, no, option A is the correct one. Okay, I guess it's a simple calculation actually. Once you just pick up the point properly that what you have to find out, then like very smoothly you can proceed to the answer. Okay, I guess you understood this concept. Let's proceed for the next one. Okay, so here you can see a mixture of phenol and aniline shows negative deviation from Raoult's law. This due to the formation of, the options are there. Okay, so let me tell you when the negative deviation, what are the causes of negative deviation. I guess you know, whenever the interaction of AB, whenever the interaction, let's make it like that, whenever the interaction of AA and BB is lesser than that of interaction between AB, that time you can say it is a negative deviation. So now you can see aniline and phenol, they are a very good companion in order to make intermolecular hydrogen bonding. Okay, phenol is having oxygen and their aniline is having hydrogen. Okay, they are very good companion to make the hydrogen bonding and intermolecular hydrogen bonding. Okay, as a result of this, the interaction between the mixture, I mean the phenol and aniline, is very strong than that of the individual mixture, right. So as a result of this, the answer is going to be C. Okay, I guess this is an easy question actually. I guess you understood this. Let's proceed for the next one. Here it is from the RLVP, that is the relative lowering of vapor pressure. Okay, so vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius, that you have to calculate. Okay, so how you should calculate Raoult's law, I guess you know. So one by one number of moles let's calculate, because RLVP is nothing but the mole fraction of solute. RLVP equals to the mole fraction of solute. So in order to find out the mole fraction of solute, you need to know the number of moles, right? So number of moles of glucose, let's find out at first. 18 divided by 180. 18 divided by 180. So definitely it's 0.1 mole. Next is water, right? Next is water, that is 178.2 divided by 18. So if you calculate this value should be 9.9 mole. Okay, now you calculate the mole fraction of water. So from here what you are going to get, here basically number of moles of water divided by number of moles of glucose plus number of moles of water. So simply if you just put the value over here, 9.9 divided by, that is 9.9 plus 0.1, that is 10, right? So from here I am getting the value 0.99, right? 0.99 is the mole fraction. Okay, wait, now let me just check. Okay, they are asking for the vapor pressure, not the RLVP directly. Okay, so once as they are asking the vapor pressure, so you can use the Raoult's law actually, not the RLVP directly. So vapor pressure from Raoult's law, what it says, the partial pressure of the solution is basically equals to mole fraction of the solvent into the vapor pressure of the pure solvent, right? Vapor pressure of the pure solvent. Okay, so in Raoult's law what we do actually, we add component A and B for a binary mixture, right? But here you can see I am having the glucose and water mixture. Glucose is non-volatile, it will not contribute in vapor pressure, right? So whatever the vapor will come out, the total pressure that is coming out from the solution, it is only because of water. So that's the reason here I am not taking X of glucose into P0 of glucose, because glucose is not having any kind of vapor pressure. So only water is contributing for the vapor pressure. Okay, so let's put the value here that we calculated 0.99 into P0 of water. Okay, so let me tell you, P0 of water, here it is given, it is 760 torr, right? So let's put it, that is 760 torr. Okay, so now if you calculate, your value will come as 752.4 torr. Okay, so you can see your answer is option B. I guess you understood this. Let's proceed for the next one. Here you can see which one of the following pairs will show positive deviation for Raoult's law. So positive deviation means what? Whenever the interaction between AA and BB is greater than that of AB, right? So you have to check if individual component A and component B, if they are having any interaction among them or not, right? So here you can see the option B is going to be the correct one. So why it is like that? Because if you just see option B, that is a benzene. So for benzene you can see A and A, like in between two benzene I am having non-polar compound, right? And if you are having methanol, I am having strong hydrogen bond. Right? So whenever methanol, in between that strong hydrogen bonding, some amount of benzene will be added in between. Some amount of benzene will be added in between the methanol. Then what will happen? Then the hydrogen bonding will get disrupted. right? So A interaction or B interaction, whatever you are saying, that will be broken, right? As a result of this, AB interaction will be more and it will show positive deviation. Okay, I guess you understood this. Let's proceed for the next one. Okay, so that is the elevation in boiling point. Okay, question is 180 gram of glucose is dissolved in 1 kg of water in a vessel. The temperature at which water boils at 1.013 bar is, you have to find out. Kb is given for the water and pure water boiling point is also given. Okay, so we will directly apply the formula, that is the delta Tb. What is delta Tb? Delta Tb is equals to Kb into small m. Small m means molality, right? See, this much you remember, and then how you should analyze the thing, how you should write the in-depth formula. In a single formula you can calculate everything actually. See, here I am having Kb value, and molality means number of moles of solutes divided by weight of solvent in kg, right? Now how I should break down the number of moles? That is a given mass divided by molecular weight into weight of the solvent in kg. Okay, let's put the value. Kb value they have given 0.52 Kelvin kg per mole, right? Here given mass is how much? Given mass they have given it's 180 gram. Okay, 180 gram divided by molecular weight is also 180 gram per mole, right? Now divided by, I am writing 1 by, okay, weight of the solvent, that is also given as 1 kg. Okay, so now also just look at the fact that how the units are also getting cancelled out and you are getting the proper unit. Okay, see, kg will be cancelled out, number of moles will be cancelled out. Okay, and here you are getting gram cancelled out. So from here 180 will be cancelled out, and hence you are getting only 0.52 Kelvin. See, only Kelvin came, that is the temperature unit, the unit of temperature, right? Okay, now delta Tb I got. Now what I have to find out? The Tb value, right? Means the boiling temperature. So delta Tb, we know delta Tb is the boiling point minus Tb0. That is the boiling point of the pure solvent, right? So this value is given 0.52. Here Tb I have to calculate, minus Tb0 is, value is given 373.15 Kelvin. This is also Kelvin. Fine. So from here I am getting Tb, if you calculate, 373.15 plus 0.52 Kelvin, and that will give you 373.67 Kelvin. Okay, so option 4 is going to be the answer. I guess you understood this. My request to you people, pause the screen and practice in your copy as well. That's really gonna help you to solve the problems during the examination time, because you will be having very less time to solve each and every numerical problems. So you have to be very much precise by that point of time, and you should not have like any dilemma, right? Which formula I need to use. Everything should be there at the tip of your pen, right? So to ensure that more you will write these formulas, more you will apply them, more you will remember in that case as well. Okay, I guess you understood. Let's proceed. Okay, it's a huge question, so I know students' mentality when they used to see this type of huge question, they try to avoid it. Okay, so please don't skip the video. See how I'm solving this problem. Maybe it's an easy one. Let's see. Okay, so you can see a sample of water is found to contain 5.8% weight by weight of AB. Okay, so whatever the information I'm having, let me write down one by one. AB is a compound I'm having, and it is present in 5.8% weight by weight. Okay, and I am having XY2. Okay, that I am having 9.50%, that is also weight by weight. Fine. Molecular mass also given. For this it is 58. It is given as 58. 58.5. Okay, for this it is given as 95. Okay. Now what they are saying, that assuming 80% ionization of AB, so for AB the ionization is 80%. Okay, and 60% ionization for XY2. For XY2 I am having 60%. Okay, the freezing point of the water sample. Okay, the freezing point of the water sample is, you have to find out. Okay, the KF value is given. Fine. So many things are given and so many things we have to do, it seems, for this particular problem. Let's sort it out one by one. Okay, so definitely Van't-Hoff factor we are going to use here. Here whenever you are going to apply Van't-Hoff factor, you have to apply with the formula that is including alpha. Okay, so simply from here let me just calculate the alpha value. Maybe later it will be needed. Alpha equals to 80 by 100, right? That is 0.8. Okay, and for this alpha equals to 60 by 100, that is basically 0.6. Okay, let's proceed one by one. As you can see, they are telling 5.8%. Percent means in 100. In 100 how much I am having, and weight by weight means 100 gram. Okay, so 100 gram let's assume as a solution. So let's assume I am having 100 gram solution, right? Because they are giving with respect to 100 only, weight by weight, right? Weight by weight means what? 5.8 gram of AB present in 100 gram of solution. Here also 9.5 gram of XY2 present in 100 gram of solution. So solution amount we can simply consider as 100 gram. Okay, now what we are going to proceed? Now simply let's calculate number of moles of AB. How I should calculate? Given weight by 58.5. 5.8 divided by 5.8 divided by 58.5. It's going to be almost 0.099 something, because it's almost okay, because 58.5 is given. Okay, now number of moles of XY2 let's calculate. How much weight is given? 9.5 divided by 95. So for this case I can directly write it is actually number of moles is 0.1. right, 0.1 mole. Okay, so for this particular case I need the mass of water as well. So mass of water is how much? Mass of water present. In my water I am having AB, I am having XY2, right? So AB is present in 5.8 gram, XY2 is present as 9.5 gram. So to calculate the mass of water present, I can simply do 100 minus 5.8 plus 9.5, right? So if you simply do it, you will get something 84.7 gram, and if you further make it kg, it will be 0.0847 kg. I guess up to these steps are very small. I guess you understood. Okay, again just go with the flow, then again I will explain as a whole. Okay, let's proceed. Now I have to find out molality of AB, okay, and I have to find molality of XY2 for both. Okay, so what is the molality of AB? Number of moles of AB, number of moles of AB divided by weight of the solvent, weight of solvent. Okay, for this case also number of moles of XY2 divided by weight of the solvent. Okay, let's put number of moles of AB was 0.099 and 0.0847. Fine, let's put the value over there. So here I am just taking 0.09 mole divided by 0.0847 kg, mole per kg, right? If you calculate this, your value should be 1.169 mole per kg. Okay, now here also let's put, it was I guess 0.1 and here it was similarly 0.0847 kg. So this is the easy one. If you calculate, you should get the value 1.181 mole per kg. Okay, so molality we got. Now let's proceed to the main part. What is the main part? First what we will do, first we will see for the AB, if it dissociates completely, I will get A plus B minus. So N value means total number of ions coming out of AB is 2. Total number of ions coming out of AB, it's 2. So let's apply the Vedantu factor formula. I equals to 1 plus alpha into N minus 1. This is the formula. Okay. When the dissociation takes place, whenever the molecule dissociates to give you abnormal molecular weight, this is the formula of I. Okay. So let's put the value here, 1 plus, here you can see alpha value we need. So alpha for AV was 0.8. So 0.8 into N is 2 minus 1. If you calculate this, your value should be 1.8. Okay. Similarly, we will do this for XY2. So XY2, if it dissociates, it will give me X2 plus 2Y minus, right? So as you can see, total number of ion, it is coming N equals to 3. So similarly again I am going to apply I is going to be 1 plus alpha into N minus 1, right? So 1 plus alpha value is, here for XY2 it was 0.6. Okay, 0.6 into 3 minus 1. If you calculate this, your answer will be 2.2. Fine. Now what you have to do? Now let's find out the delta TF. Okay, so delta TF is coming because of this solution and this solution as well. So simply just add them. What was the formula, in general formula of delta TF? Delta TF equals to I into KF into M, but here I am having two components, so add the two components individually. So I am going to do I of AB into KF. KF is going to be it is similar because it is soluble in the same solution, water, right? KF into molality of AB, okay, plus I of XY2 into KF into M of XY2. Okay, let's put the value and add them. So let's take the KF common. Okay, and here I am having I of AB. I of AB is how much? I am getting 1.8, right? 1.8. So 1.8 into molality of AB is coming 1.169. 1.169, right? Plus here I of XY2, it's coming 2.2, and into, if I write KF value, KF is taken outside, molality is coming 1.181. Okay, so here the unit was mole per kg. Here also the unit was mole per kg. Fine. So let's put the value of KF as well. Okay, let's put the value of KF. If you put the value of KF from the question, it's basically given as, where it is given, 1.86 Kelvin kg mole inverse. Okay, so if I put the value of KF directly, I am putting it here. So I am having 1.86 it's Kelvin kg mole inverse. Okay, so as a result of this, you can see mole inverse will be cancelled out, kg inverse and kg will be cancelled out. So overall I am getting Kelvin only. So if you do entire this plus minus and multiplication calculation, minus, so you don't have to do minus, only the multiplication and add, you will get the value delta TF as 8.746 Kelvin. Every units will be cancelled out. Okay, the job is not yet done. Now delta TF, you have to find out the freezing point, right? So delta TF equals to T0 means at the pure state, okay, freezing temperature, freezing point at the pure state, okay, minus TF, right? TF you have to calculate. Let's put the value 8.746 and TF0, if it is given, let me check. TF0 273 Kelvin. Okay, so let's put TF0 here, 273 minus TF. So from here your TF is coming 273 minus 8.746 and your answer is going to be 264.25 Kelvin. This is the answer. Okay, Let's see. Yes, option A. Okay, now let me just, while I'm just explaining, please make a note of it. So, majorly you have to find out the freezing temperature, right? You can see the freezing point of the water sample you have to find out, right? So, to find out TF, definitely you have to proceed to delta TF. Delta TF requires what? Delta TF requires molality. Okay, from where you will get the molality? To understand, to find out the molality, you need the number of moles. From where you will get the number of moles? From these values, right? So you can see AB is given this percentage, XY2 is given this percentage. From there, what I calculated, the number of moles separately, right? And I assumed the water sample present as 100 gram because percentage weight they have given. So I can take it as 100 gram. Okay, and the mass of solvent also you need in kg in order to calculate molality. So that also I calculated here. How? The solution weight minus the solute weight, right? That's what I did here. Now you can see I calculate the molality of AB and XY2 individually. Number of moles divided by the mass of solvent. I did it. Now what I need, for this particular case, I have to multiply this thing delta TF with I need to calculate the I as well. So how I should calculate I? I formula is 1 plus alpha into n minus 1 for the dissociation, right? So dissociation, like AB, how it will dissociate? A plus B minus, number of ions are coming 2, right? Now put the value, everything. Alpha value they told 80%. So 80 divided by 100 and hence 0.8, right? 0.8 into 2 minus 1, you are getting 1.8 overall. Here also same thing, and I am getting 2.2. Now accumulate all the thing in the delta TF and add them because you are having two solute over there, right? One for AB, another for XY2. By adding them, I am getting the delta TF value at 8.746 Kelvin, right? So now delta TF value, from there I am going to calculate the freezing point. Okay, so delta TF is the freezing point at the pure case minus the freezing point whenever it is a like solution phase. So if you put the value and find out the TF, it is coming as 264.25. I know it's a huge one, it's a big one, a little bit complicated, but if you understand step by step, it will be easier, I guess. I guess you understood this problem. Let's proceed for the next one. Okay, so after doing a very hectic question, you are getting a very small one. You can see a small one, better to say it's a direct one. Okay, the swelling in feet and ankles of a aged person due to sitting continuously for long hours during the travel is reduced by soaking the feet in warm water. This is because of, you are getting the option reverse osmosis, edema, diffusion. So what I have seen people doing, people with rush, they mark in edema. Let me tell you, this particular condition, there is a medical terminology for this condition, that is edema. It's not the scenario in the sense why this is happening. It's not the reason. Edema is the name of the condition. Okay, so don't mark edema. So basically what happens, whenever you are sitting, then your tissue gets accumulated with the fluids, right? And whenever you are putting them into the solution, warm salt water solution, then it is creating a hypertonic solution, and that osmosis takes place from the tissue to outside, right? So osmosis is going to be the correct one, not edema. Edema is a medical term of this particular condition. Okay, I guess you understood. Let's proceed for the next one. Okay, here you can see which of the following colligative properties can provide molar mass of protein, polymers and the colloids. Okay, so this is also a direct question. You can mark it is a osmotic pressure that we often use to calculate the molecular weight of proteins and all this type of huge biomolecules. Okay, let's proceed for the next one. Okay, if 3 gram of glucose, you are having, the molar mass is also given, is dissolved in 60 gram of water at 15 degrees Celsius, then the osmotic pressure. Okay, this is also an easy one. So you can see we know pi equals to CRT, right? So C can be written as N by V, number of moles in volume, RT, right? Now number of moles also can be written as given mass by molecular weight, okay, into RT by V normally. Now let's put the value what they said. 3 gram of glucose, 3 gram divided by molecular weight of glucose is 180 gram per mole, okay, into R value you should take is a universal gas constant. It is 0.0821 liter atmosphere per mole per Kelvin, into I'm having the temperature is how much? 15 degrees Celsius. So 373.15 plus 15, you are having 288.15 Kelvin, divided by I am having the volume is, okay, 60 gram they said. You know the density of water is 1, right? So for that particular case you can just compare 1 liter is equals to 1000 gram, okay. So unitary method actually you can use. 1000 gram is equivalent to 1 liter, and hence 60 gram is equivalent to 60 divided by 1000, right? So definitely you are going to get 0.06, okay, that is the in liter. So if you calculate the entire thing, gram will be cancelled out, mole inverse will be cancelled out, here Kelvin will be cancelled out, liter will be cancelled out, you are getting only atmosphere, okay. And if you calculate the value, it will come as 6.57 atmosphere, okay. So option A is going to be the correct one. I guess you understood. Let's proceed for the next one, okay. Okay, the dimerization of the solution molecules in low dielectric constant solvent is due to, it's a direct question, you can directly say that hydrogen bonding, okay. So let's proceed for the next one. Among the following 0.1 molar aqua solution which will exhibit the lowest boiling point elevation, assuming complete ionization. Here what you have to calculate, all of them are electrolytes, so you have to calculate the I value, okay. How you should calculate? You can see Al2SO4 whole thrice, one by one I am doing here. You can see Al2SO4 whole thrice, okay. So if it dissociates, it will give you 2Al3 plus 3SO4 2 minus, okay. How many ions you are getting? Total 5, hence I will be 5, right? For K2SO4 similarly, if you do it, 2K plus SO4 2 minus, hence I is coming as 3, total ions 3. Sodium chloride, NaCl, you know I am not doing it, Na plus Cl minus, hence I is coming 2. Count the number of ions it is forming after getting dissociated, okay. Aluminium chloride if you dissociate, it will come as Al3 plus 3Cl minus, right. So how many ion you are getting? I equals to 4. So for the NaCl I am getting least I, okay. So now I know delta TB equals to I into Kb into M, okay. So list the value of I, lowest the boiling point elevation. This is the boiling point elevation, right? This entire thing is the elevation in boiling point, EBP, elevation in boiling point. So when the value will be least? If the I is least, right? So this is for the case of NaCl. I guess you understood this. Let's proceed. Okay, so here we are going to proceed with the chapter chemical kinetics. Okay, so let's proceed with the, so that's all for the solution. We covered almost every possible zone, okay, and we targeted the very famous zone from where the repeated year question used to come. Okay, so now let's proceed with the chemical kinetics. Please make sure that you are doing enough pen and paper work while just going through this video. Okay, so first question in chemical kinetics: the rate of a gaseous reaction in the expression this, if the volume of the vessel is reduced to 1/2 of the volume, the reaction rate as original rate is. Okay, so initially let's say R1 was given, that is K into A into concentration of A into B square, right? It's a R1, let's take it as R1. So basically let me tell you, concentration is inversely proportional to volume, right? C equals to N by V, hence it is inversely proportional to volume. If you increase the volume, let's just make it like that, if you decrease the volume, concentration will be increased. So how much you are reducing the volume to half, means if you are reducing the volume to half, your concentration will be 2 times, right? So the new rate R2 will be something like K into both the concentration will be increased by 2 times, right? 2 of A into 2 of B whole square, right? So if you calculate 8 into K of A into B square, I can write this. From here I can see R2 is basically 8 times of R1, right? So option C is going to be the correct one. Okay, so let's proceed. Okay, for the reaction 2N2O5 gives 4NO2 plus O2. Initial concentration of N2O5 is 2 mole per liter, and after 300 minutes, okay, it is reduced to 1.4. okay, it's a 1.4. okay, don't take it as is2, it is 1.4 mole per liter. So rate of production of NO2. So for this type of question, directly write the rate equation at first. Once you are done with the rate equation, you will get the entire information how you should proceed further. Okay, so for that particular reaction, it is the rate equation ROR, rate of reaction, it's going to be minus 1/2 concentration of N2O5 divided by change in time. Okay, delta of N2O5 divided by delta T is equals to plus 1/4 delta NO2 by delta T plus 1 equals to nothing, no stoichiometry is there, hence delta concentration of O2 divided by delta T, right? That is the rate equation. So now let's see what information they give. Initial concentration of N2O5. okay, so let's say N2O5 I initial is given as 2.0 mole per liter, right? Okay, and after 300 minutes, final concentration is N2O5 F. F means final. It is 1.4 mole per liter. Okay, now delta N2O5, let's calculate. Delta N2O5, it's nothing but the final minus initial, hence from here I am getting final is 1.4 minus 2.0 mole per liter, hence I am getting what? I will get around minus 0.6, I guess. Yes, minus 0.6 mole per liter. Fine. Now let's calculate this term. Okay. So hence, if I write rate of disappearance of N2O5, that is nothing but the delta N2O5 divided by delta T. This value is given. All the values are given here. Minus 0.6, I just calculated, mole per liter, divided by time is also given, that is the 300 minute. Right? If you calculate, you will get 2 into 10 power minus 3 mole. Right? So whenever I am taking the rate of disappearance, you can simply consider it in a mod. Okay? You can simply consider it in a mod. Because whenever I am using the term rate of disappearance or something, then by default it is considered. By default it is taken. Okay. So now how I should proceed? I have to find out rate of production of NO2. Rate of production of NO2. Now from this particular equation, take this term and take this term and equate them. Okay. That will work. So I am having this particular term, that is, let's put that 1 by 2 of delta N2O5 divided by delta T is equals to, okay, here one minus sign was there, equals to 1 by 4 of delta NO2 divided by delta T. Okay, any two part I can equate as of my wish, whatever is, it is something on the basis of my need, right? So now what is the rate of appearance? Rate of appearance of NO2 can be written as delta NO2 by delta T, right? You can see that term is already there, right? So let's cancel out, 2 gets cancelled out, here 2, so this 2 will be multiplied here, and hence I am getting something minus 2 of this value. This value is coming how much? This value is coming minus 2 into 10 power minus 3. 2 into 10 power minus 3, right? And here I am getting, it is delta NO2 by delta T, right? So simply if you calculate this, your delta NO2, that is the rate of appearance of NO2, that only they asked, rate of production or appearance is the same thing, rate of appearance or production of NO2 with respect to time, it is going to be something 4 into 10 power minus 3, right? And the unit is going to be mole per liter per minute. Okay, so let's see what's the correct answer. It's option 3. Okay, so I guess you understood this. At first I simply find out the whatever the data is given, with respect to that I can only calculate this much, that is the rate of disappearance of N2O5, right? Because it is a reactant gets disappeared with time, that's why rate of disappearance, it coming 2 into 10 power minus 3 something. Okay, now actually they are asking for these particular value, so I can equate them from the rate equation, and then by comparing I am getting this value. Okay, let's proceed for the next one. Okay, let's proceed for this question. So here you can see the question is, in which of the following reaction the rate constant unit is mole per liter per second. So here by looking at the unit you can understand it's a zero order reaction. Okay, because only for the zero order reaction rate constant unit is similar to that of the rate itself, right? So now you have to check for which case it is a zero order reaction. So just looking at the equation I can tell that the last one, that is a decomposition of HI on the surface of gold. Let me tell you initially if you just normally decompose HI to get H2 and I2 without any gold surface, it's a second order reaction. But whenever you are using a gold surface, on the gold surface any decomposition reactions are always zero order reaction. Okay, it's an experimental data. So whenever it is seen that any kind of hydrogenation reaction or anything, any reaction is done on the gold surface, on gold surface that particular reaction becomes zero order reaction. So this is going to be the correct one. Okay, let's proceed for the next one. Here you can see the rate of the reaction for this particular reaction. It is a base catalyzed hydrolysis of ester. Okay, it is an ester group and here you are having base. Is given by the equation this. If the concentration is expressed in the term mole per liter, what is the unit of K? Okay, so if I just normally write R, if we simply write the R value, R will be equals to K into CH3 COO C2H5 into NaOH, right? Now if you want to find out K should be equals to R by 2 concentration term. I'm just writing it like this, 2 concentration term. So what is the unit of R? Unit of R is mole per liter per second, right? And here also once I have to write mole per liter for one concentration and again I have to write mole per liter for another concentration term, right? So 1 mole per liter is getting cancelled out, liter, fine. So as a result of this, this liter will go up and hence liter per mole into second inverse. That's going to be the unit of K, right? So option A is going to be the correct one. Okay, let's proceed for the next one. So the question is, for the reaction PCl5 gives PCl3 plus Cl2 rate and the rate constants are given like that. Okay, at a given instant, the molar concentration of PCl5 you have to find out. Okay, it's also a very easy one. You can see the rate for this reaction is going to be simply K into concentration of PCl5, right? Everything is given here. Concentration of PCl5 you have to find. So it should be R divided by K, right? So R value is given something 1.02 into 10 power minus 4 mole per liter per second divided by K is also given, that is 3.4 into 10 power minus 5, it's a second inverse. Okay, by just looking at the unit you can understand it's a first order reaction. Okay, second inverse will be cancelled out and if you calculate this it will come as 3. Okay, so your answer is 3 mole per liter. Okay, so option B is going to be the correct one. Let's proceed for the next one. Okay, so if the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by what? Okay, so first you can see at any time, at any instant, at any time that is time t, let the concentration of A be AT. Fine. So there 99% is always already finished. So how much is left? 1% only. So 1% means what? 1 by 100, that is 0.01. Okay, now simply just put it into the first order integrated late law equation, that is 2.303 divided by K into log A0, what is AT? A0 into 0.1, anyway. So now if you just put the value over there, 2.303 divided by K into log A0 will be cancelled out, this will go up, hence 10 square, and from here you are getting 2.303 into 2 divided by k. I guess you understood 2 will come front and log 10 value is 1, right? For this case 4.606 divided by k. So A is going to be the correct answer. I guess you understood this. Let's proceed for the next one. Okay, so here comes the half-life concept. Half-life of a first order reaction is 20 seconds and initial concentration of the reaction is, for the reactant is 0.2 molar. The concentration of the reactant after 80 seconds. Okay, it's a very trendy question. This type of question often comes, okay. High alert zone, I'm telling. See how you should target this type of question. First order half-life is something 0.693 divided by T, right? T half. So T half value is given, that is 0.693 divided by 20. So from here I can get the value of K. So if you calculate, it will be almost 0.03465 second inverse. Okay, because it's a first order reaction, second inverse. Fine. So K is done. Here K I got. Now put all the datas in the first order integrated rate law. 2.303 divided by K into log. Okay, initial concentration they told 0.2 mole. Okay, divided by, I don't know, 80, that I have to calculate. Fine. T I know, T is 80 second, and 2.303 divided by K value is given. K I got, I calculated 0.03465. Okay, and here I am getting log 0.2 divided by 80. Anyway, by default I am not putting the unit over here to it will be looking more complicated. You can definitely understand, if it is 0.2 molar, then definitely this denominator value also should be in the molarity only. So whatever the concentration 80 will come, it will come in molarity. Fine. So simply if you just calculate 80 into 0.03465 divided by 2.303 equals to log 0.2 by 80. So if you calculate this particular side, it will come around 1.2. 1.2 log 0.2 divided by 80. Now if you want to do anti-log, it should be 10 power 1.2, right? So 0.2 divided by 80 is going to be 10 power 1.2, right? Hence from here I am going to get, I am just taking it here, from here I am going to get 0.2 by 80, the value will come as 15.8. Okay, so from here 80 will come as 0.2 divided by 15.8, and hence your value will be almost equals to 0.013 molar. Okay, so I will be taking the close by value. What is the close by answer? You can see option 2 is the closest answer. Okay, I guess you understood this. It's just a matter of calculation. You can, if you can handle this type of things, then it's okay. So we will be making different videos on different chapter, which are mainly numerical based. Okay, there I will tell you how to calculate this type of log, or how to calculate anti-log, how to calculate 10 power something in point. Okay, something in decimal. Okay, how you should deal with those things. So to know all those tips and tricks, please subscribe and keep watching our videos. Okay, so let's proceed further. You can see again same type of question. First order reaction is half completed, half life you can see it is given, so 99%, like how long it will take. Okay, so let's proceed with the same pattern. So T half is given 45, so K I can get directly 0.693 divided by 45. From here I am getting 0.0154, right? Second inverse I can write. If you calculate, it will come 0.0154. Fine. Now first order equation, let's put 2.303 divided by T into log, here A0. What is AT? 100 minus 90, here you can write 100. Here you can take it as 100. Okay, so because full concentration I am starting with, let's see, it is 100. Okay, so here A0 I am not writing. If I am writing 100, just a minute. So I am simply starting with 100. Okay, now 100 minus 99.9, if you do, it will come as 0.1, right? So if you calculate, this will come as 10 cube. So simply calculate this. T equals to 2.303, put the value of K from the equation, 0.0154 into log 10 cube. Okay, so if you calculate, your time will come as 448.5 minutes, and if you convert it to, this will come in minute. If you convert it to hour, because you can see all the options are given in hour, so 448.5 divided by 60, you will get almost equals to 7.5 hours. So option D is going to be the correct one. I guess you understood. Let's proceed for the next one. Okay, so now here you can see for a reaction, the value of rate constant is given, that is at 300 Kelvin, 6 into 10 power minus 5. What is the value of A? A is the pre-exponential constant or the Arrhenius constant, whatever you want to say that. So let me write down the Arrhenius. This particular topic is from the Arrhenius equation. Okay, so K equals to A into e power minus EA by RT, right? So from here, see, they are saying T tends to T tends to infinity, right? Because you can see at infinite high temperature, so T tends to infinity. So if you put T tends to infinity, then EA by RT, it should be 0, and now e power 0 is nothing but 1, right? So problem sorted. So K equals to A into 1, hence K and A value is quite similar. What is the value of K? 6 into 10 power minus 5. 6 into 10 power minus 5. So this is going to be the answer. I guess you understood. Let's proceed for the next one. Okay, so here you can see for the reaction A gives B, EA value is given. EA means energy of the activation, and del H also given. When the catalyst is added, EA decreases by 10 kilojoule. What is the EA for the backward reaction? Okay, so you just apply a little bit brain. How? Because del H value is given. Del H for a reaction is given by energy of activation for the forward reaction minus energy of activation for the backward reaction. Fine. So from here I can find out the EA of backward reaction, right? EA of backward reaction is going to be EA of forward reaction minus del H. So put the value here, 50 kilojoule, that is given over here. Yes, 50 kilojoule per mole minus, there also again one minus 20. Okay, outside the unit is kilojoule per mole. Fine. So if you simply calculate this, your EAB should be 70 kilojoule per mole. Okay, your EAB should be 70 kilojoule per mole. Now EA backward. Okay, so that particular thing should be reduced because you are adding some sort of catalyst here, right? So from here, if I just find out EAB in presence of catalyst, so definitely it should be EAB, the original value, this value, minus the decrease due to presence of catalyst, okay. So EAB value, how much I am getting? 70, and how much decrease because of the catalyst? You can see 10 kilojoule, 10, okay. So I am getting overall 60 kilojoule per mole. So A is going to be the correct answer. I guess you understood this. Let's proceed for the next one. Okay. So it's a direct question, it seems. Catalysts are used to increase the rate of a chemical reaction because it first decreases activation energy. So definitely that's gonna be the correct answer. So definitely it actually decreases the activation energy. So if you just simply, this is my potential energy and this is my reaction coordinate. If you, this is my reactant, this is my product. If this is the journey of a reactant, now in presence of catalyst, the journey will be something like this. You can see initially the activation energy was something this much, but whenever you are adding the catalyst, your energy of activation is this much. So it is decreasing the activation energy. So your 30 PYQs are done from the solution and chemical kinetics chapter. Rest of the chapters also we will proceed thoroughly. So to get full information along with the tips and tricks and the proper concept, stay tuned, keep watching our video, and also don't forget to like, share and subscribe. Thank you so much.